So now that we've talked about some of the anatomy, we can start looking at gametogenesis itself. So looking at gametogenesis, we're starting by looking at these interstitial cells. So these interstitial cells are these sets in between here, where we're looking at hormones and stuff, and then we've got these developing stem cells in the seminiferous tubules. So for gametogenesis to start, we start from these primordial germ cells that then divide into these spermatogonial stem cells. And that's what we're looking at in an adult male, where we're looking at the start of this gametogenesis. From this spermatogonial stem cell, it'll divide, and it'll divide and produce more stem cells, but it will also undergo a division to produce spermatogonium, which a spermatogonium is then going to divide and start producing a primary spermatocyte. Now at this point we have this primary spermatocyte. It's a normal 2N cell. So it's got one copy of each set of genetics, of genes from the mother, from the father. Then we're going to get this division into our secondary spermatocytes, where we have just the one N. It's going to divide into these, so it's got extra copies, but it's just this duplication. And then we're going to divide into these spermatids, each of which will be a single copy cell. So it doesn't have both copies. It's not diploid. It's a haploid cell. So now we have these haploid cells, and these haploid cells then will form into these final sperm. And so these form in the testes and migrate from the testes as these final sperm into these ductules, which will carry them into the epididymis. So we have this process here of they're being formed in the seminiferous tubules. They will start in these walls of the seminiferous tubules, migrate out to the lumen, and when they reach the lumen, they're these fully formed cells. So we have these Sertoli cells here that are supporting them. You have the germinal cell, the primary spermatocyte here, the secondary spermatocytes, and then finally these spermatids. And these spermatids are going to go into that lumen and migrate and wind up here into this epididymis, where they will mature and go through a selection process, removing damaged or imperfectly formed sperm. And so there's this twisting, turning tubules that they're going to be flowing through. And as they flow through this, there's all of these checks going on, and we'll be eliminating a lot of the malformed ones that can't sort of get through this process. Now, in addition to the sperm forming function here, we have to think a little bit about the hormones. And this feedback loop should look familiar to we've talked about this in the endocrine system before. So we have the hypothalamus here producing gonadotropin releasing hormone, and that stimulates the anterior pituitary to produce FSH and LH. Hopefully you remember this from Chemical Eric, who wasn't producing these. Now the LH is going to go to the Leydig cells of the testes and start the production of testosterone, which of course comes back and inhibits this. The FSH is going to go to the Sertoli cells and start the production and start that spermatogenesis. Now, testosterone enhances spermatogenesis, but it sort of acts on spermatogenesis that's happening. Without this stimulation of the Sertoli cells by FSH, we don't have spermatogenesis. The Sertoli cells are also going to produce inhibin, which is going to do what its name sounds like. It's going to inhibit the anterior pituitary, preventing the production of FSH and LH. So you have this cycle where you've got your classic negative feedback loop. And of course, if you've got excess testosterone in the body, it's going to inhibit these and prevent the production of FSH and LH, which will then prevent spermatogenesis. So too low testosterone means that it's not enhancing spermatogenesis here, but too high testosterone, like from exogenous testosterone sources, will actually shut this down as well. So now that the sperm has been produced, to actually get that out of the body, it's not just the sperm that leaves the body, it's a whole semen mixture. And that semen mixture comes from a whole set of these glands that are producing things that join the sperm. So here's the vas deferens. The sperm have come from the epididymis back down up this vas deferens, and now we're getting to the area where it will join together to produce semen and be released from the body through ejaculation. So our first one is the seminal vesicle. The seminal vesicle produces the majority of the fluid that actually goes into the semen. It produces a liquidy fluid that has sugars and salts that are going to provide the environment that the sperm needs and the energy that the sperm needs. So here you can see it looks like a pretty standard secretory gland. We have these epithelial cells surrounding a lumen. In this case, we're looking at pseudostratified columnar epithelium with this sort of standard gland structure. And these are going to produce that fluid. Then we have the prostate. The prostate also contributes to this fluid, contributes materials to make the content of this fluid match the sort of needs of the sperm. And the prostate surrounds the urethra, and that's part of why in older men often the prostate swells, and that can compress the urethra and push on the bladder, causing problems with urination and urinary frequency. Then finally, we get down here to the bulbourethral glands, and this is where a lot of that mucus comes from that thickens up the semen. So it's not just watery, but it's sticky and thick. So now we've had the sperm produced in the testes. They go up through the epididymis. They go through the vas deferens, come back down here. The seminal vesicles add the fluid. This prostate gland adds additional materials. The bulbourethral glands add mucus. Now we reach the urethra, which will of course exit through the penis, and the semen will pass out through there. Now, for that part to work, we have to talk about what's going on in the penis. So the penis is this erectile structure, and the erectile part comes from this corpus spongiosum and corpus cavernosum that fill with blood and become firm and elongated. Now we can look down here, we see the glans, which is the sort of sensitive part at the end, where we're also seeing the urethra exiting. In an uncircumcised person, you would have a prepuce, a foreskin, wrapping around this as a protective part. But running through this, we have these erectile tissues, we have the blood vessels, and of course we have a lot of nerves. So these are the things we're going to look at. And here's the prepuce again, the foreskin. So in an uncircumcised person with a penis, you'll see the foreskin covering the glands, and that can retract. Generally, it will retract in preparation for intercourse during erection. It can also be retracted other times. So we're back at this structure, and then for erection to occur, blood flows into the corpus cavernosum and the corpus spongiosum, causes those to become firm and larger, and pushes the penis to be hard and erect. Now, so here we have a look at that process with the excess blood flow coming in and causing this erection. So now once you we have that, oops, sorry, that is no longer relevant. I thought I had pulled it out. So once we have that, then we could there's also ejaculation. So stimulation is going to cause the muscles around the testes to contract, cause the testes to release the sperm, and cause this whole process that we talked about with all of those glands to happen, and was going to pump out through the penis by muscular force, all of which is stimulated by the sympathetic nervous system. All right, and that brings us to the end.